Okay, gentlemen, I'm going to try doing 2.3's handout with a Zoom video. Just going to see if this works, and if so, it'll be helpful, I think, for a lot of you on using your graphing display calculator. So let's take out our 2.3 day one handout. I'm going to share my screen with you, and I pulled up my GDC, so it's important to have your GDC ready. Pause the video and get that if you don't have it on you. So it says here, must have graphing calculator, must have graph paper. And what we're going to try and learn is how to create a scatter plot on graph paper and on a graphing display calculator. Another learning goal here to determine the relationship between the independent and dependent variables and to recognize an outlier, something that lies outside the data. So the scatter plot below shows the number of hours studying for a math exam and the mark each student received for 14 randomly selected students. So you notice here it asks us what the independent variable is, what the dependent variable is, and any outliers. So this is our data here, okay? And what we're trying to find is a trend. If you notice when you're reading the graph, you always read these left to right in that direction, and you notice that they're kind of going up on an incline. So we call that a positive relationship. As the number of hours studying increases, it seems like the mark is also increasing. So the more you study, the better your mark is. Okay, so that is a trend. But the question is asking us about independent and dependent variable. So one of them depends on the other. I'm going to give you a little gimmicky kind of silly thing to memorize it. A lot of kids were taught in elementary school the y-axis, y to the sky. Okay, another thing that I do is say, why God, why, right? Some people question the Lord. She's like, why God, why? So you're looking up to the sky, why God, why? Okay, but the fact that you're asking why God, why means you're dependent. So the y-axis is dependent. If you're asking why, you're depending on somebody. In this case, I'm saying God for the answer. So the y-axis is the dependent. Okay, it depends on what's happening on the x-axis. The x-axis, in this case, hours, is independent. Okay, so your mark depends on how many hours you study. How many hours you studied doesn't depend on your mark. You don't say, oh, you got an 80, you must have studied 3 hours. Or you got a 95, oh, for sure you studied 4 hours. It doesn't work that way. But you could assume that the relationship is such that the more you study, the more hours you put in, the higher your mark will be. That makes sense, right? So your mark will depend on how much you study. Now, in this case, you could have an outlier, right? You could have a dot, for example, over here, up in the 90s, okay? That dot, I'm just gonna put a circle around it. You could have a dot there. So someone studied only an hour, got an amazing mark. Maybe they studied this material before. Maybe they've taken this course before. Who knows? Maybe they had some tutoring right before the test. I don't know. You also could have someone who studied many hours, I'll draw another dot, and got a mark down here really low. What happened? Maybe a bad day. Maybe they got some bad news. Their dog died, something happened, or they blanked out. They studied the wrong material. They studied for 6 hours, but they studied for the wrong chapter. I don't know, something like that. That would be an outlier, and we would try and explain the outlier. Okay, in this case, I don't see that. It looks like the dots are pretty tight knit together and in a trend. Now, when you're drawing a trend line or a line of best fit, the goal is to try and go right through the data. We're not trying to touch the dots, the first dot, the last dot. You want to try and draw a line so that you have an equal number of dots above the line and below the line, okay? So I drew one that looks pretty decent. That would be a line of best fit, okay? That's our trend. So with our graphing display calculator, eventually what we're going to do, and even on paper, you'll draw a line of best fit or create one on your graphing display calculator, and then any future questions we answer, we'll use the trend line, not actual coordinates given. We're not going to worry about those specific dots. We're just going to draw the trend line and use that to answer questions about what might happen after 6 hours or what might happen at 2.5 hours. So I see at 2.5 hours, there's no dots, but I could use my graph and say that is the 2.5 hour mark. So based on my grid or my line of best fit, I might be able to answer questions about what happens at 2.5 hours. If you studied for 2.5 hours, again, following this line here, it looks like you get somewhere in the high 60s, okay? So that's something that we can use. That's called interpolation, but we'll get to that. So for now, the independent variable is the person's, is the number of hours, Okay, and a dependent, we said already, was the mark. The answer key I'll provide for you on EDSB will be neater than this because I'm writing on the back of my computer screen. It's not as neat. Any outliers? We didn't see any outliers. I explained that we could have had some, but right now, according to this data, there's none. All right. And then here, number 5 says, this table shows, you can see I took this from your textbook. This table shows the distance it took a car to stop when traveling at various speeds. Okay, so the speed in kilometers is the first row. And then the stopping distance, obviously the faster you're traveling, the longer it'll take you to stop. But in this case, it gave us speed in the first row, stopping distance in the second row. Now, just so you keep this in your mind, 99.99% of the time, when you're given a graph or a chart or some data, if it's written in columns, the first column almost always is the independent variable or the x-axis, and the second column is the dependent or the y. In this case, we have speed as our first row. It's our independent variable, and the dependent or the y-axis will be the stopping distance. How long it takes you to stop depends on how fast you're traveling. This relationship is a little more common sense. So it says make a scatter plot. Now, I will pull up the answer key in terms of doing a written version because that's important, but I do want to use this video to show you how to do it on your GDC. So have that out. And what we're going to do on the GDC is we're going to go to the stat button. You see it's highlighted in red there. Hit the stat button because the information in this, the speed and stopping distances, those are data or statistics. So we hit stat and option 1 here says edit. So when you're selecting options in the GDC, you can either use the up and down arrow keys, for example, like this. So go to option 2, 3, 4, 5. I can go up and down, or if I know which one it is, for in this case, it's option 1. So again, sorry, I can scroll up and down and hit enter on that option. Or for example, I know this is number 1. So I'm just going to hit number 1 on the calculator and I selected it. Once you hit number 1, you should have this on your screen. Okay, list 1, list 2, list 3, L4, L5. Now, list 1 is going to be the information that we have in list 1. So I'm going to go ahead and put in 40 in my calculator, enter. Okay, notice my cursor, let's go delete that for a second. My cursor was right there. Okay, I hit 40. Oops, that was 4. I made a mistake. So I'm going to go back up and hit 40, enter. Then 50, enter. 60, 70, 80, 100. You got to be careful here and look at the information because it goes 40, 50, 60, 70, 80, 90, 100, and then it goes 120. So be careful you don't get in the habit of, oh, I know exactly what's going on here, and you just keep writing them in the wrong order. Then it goes 140, then it goes 160. So it goes up by 20s, not 10s at the end. Then I'm going to use my right arrow and tab over to the right, and I'll have list 2. List 2 will be the stopping distances. So in this case, 12, 1, 2, enter, 14. Make sure you're typing those in properly. Don't try and rush. Okay. You can pause the video if you like or what have you, or try and keep up with me here. Okay. Now, one of the most important things you want to check is now that I've entered the data, you take a look here. I'm noticing that 160 and 159, they line up. I want to make sure that happens. If you made a mistake and there's too many in list 1, for example, and less in list 2, what's going to happen later when you go to graph the information, the calculator is going to say error dimension mismatch. And what that means is these are all coordinates, 40 on the x-axis, 12 on the y-axis, 50 on the x-axis, 14 on the y-axis, and so on and so forth. Just like the last one, 160 on the x-axis and 159 on the y-axis. But if they're mismatched, you've got too many of one and not enough of another because you made a mistake, it's not going to graph anything. It will not graph any of your coordinates to say, hang on a second, this doesn't match up. You asked me to graph something and I don't have the ordered pairs just don't line up properly. And so it will not do the information, graph that information for you. Okay, so now we have this information. We want to see it on our graph. So logically, I would go to this button in the top right corner of my calculator, hit graph. I've got nothing there. Now, I'll explain a couple of things here. The graphing calculator by default, now you may have a different screen on your calculator, but if it was wiped out, clean, and reset like mine was before I started, you would see this. And what it does is it goes to 10 on the y-axis to -10. And on the x-axis, it goes from +10 to -10 as well. So 10 all around, okay? And we don't see anything. Well, it's obvious I shouldn't see anything because if I look here at my data, it says the first coordinate was 40, 12. And my screen on the calculator just has up to 10. So I shouldn't see anything. But there is a cool option on the calculator that can allow us to zoom in on the data that we just put in. And that is this button right here. And it's going to cause an error. And I'll show you in a second though. So hit this, see that in the middle there, it says zoom. Hit the zoom button. On some calculators, you have to scroll down. You don't see all 9 options. But I'm just going to let you know, no matter which calculator version you have, you're going to know right now that if you zoom and hit number 9, it zooms in on your stats. Remember we hit stat edit? It's going to zoom in on our stats. So I can hit zoom. I already did hit zoom and hit the number 9 button on my calculator. And it should be zooming in on my stats, but it's not. And that's kind of weird, but it's also not. And here's why. The calculator is very obedient, right? It only listens to what you tell it to do, and it won't go ahead and do things without you giving it permission or without you turning on certain functions. If you want to turn on this plotting of statistics function, and the reason why I'm saying this is because the calculator can take 2 pieces of information. For example, that line of best fit that I drew before, eventually we're going to learn how to write the equation of that line. And the equation is written in a format called y equal mx plus b, or slope y-intercept form. If you knew the equation, you could just type the equation in the calculator and it'll draw that line for you. The problem is we don't know the equation. We are first creating a scatter plot, and then we can come up with the equation of line of best fit. But before you even do that, you need to see the dots, the data spread out on a chart to see if there is a trend. Is it curved? Is it a linear relationship, non-linear? What's going on here? Is it a positive slope, negative slope? We first want to see what's going on before we can draw a trend line or a line of best fit or a curve of best fit. So the calculator right now, you can enter the actual equation for the line or the curve, or you enter the data. We entered the data. But if you look here, the y equal button, every single button, by the way, on your calculator has a second function. Right? You don't want, your calculator would be pretty massive, but to save space, every button on the calculator could do 2 things. So if you look above all the buttons, you see things in blue here, right? Things in blue. And so the second function button on this calculator happens to be blue. On yours, it could be orangey, yellow. That's no big deal. But if you see the y equal button above it, it says stat plot. That's the function that I want to use. So I'm going to hit second function and then the y equal button, and it opens up that stat plot menu. You see how it says number 1, plot 1 off, 2 off, 3 off? Well, basically, it's not plotting statistics unless we turn that function on. So what I'm going to go ahead and hit enter because I'm already highlighted stat plots 1. So hit enter and see how the cursor is flashing on the word on. It's actually off, but it's flashing on the word on as an option. So hit enter there, and you'll notice that now it's on the word on only. Okay. Now we can go back to graph. Top right corner. And again, it's not going to graph. But if we zoom 9, remember it was zoom, hit zoom, option 9, zoom in on your stats, ta-da. Now, because we turned that function on, it's going to zoom in on our statistics. Now, I don't know about you, but on my version here, it looks like that's a little bit more of a curve of best fit as opposed to a straight line, right? Those dots are starting to climb. So the question, the learning goal, don't forget, it didn't ask us to do a curve of best fit, just said be able to do a scatter plot on a GDC. So we just did a scatter plot. Okay. So if you've got that far today, awesome. That's all I wanted to get through today for you, but I will show you the completed version of your handout as well. 2.3 day 1. Here it is here, I thought. Let me just close this then. You know what? Let me stop sharing that and I will grab this share. Where are you? 2.3 day 2. That's not what I wanted. I wanted 2.3 day 1. Okay. So I have to screen share that. Sorry, guys. 2.3 day 1. That's what I wanted to show you. Okay. I'm not sure why it didn't come up. All right. So there's hours, mark none. We had that before. Okay. And then I just took that information, gave the graph a label. We did the same thing in our GDC, but we don't have labels anymore, etc. So you should put the speed in kilometers, the stopping distance, and go ahead and graph this. Now, whenever you're graphing, keep this in mind. You want to try and use your x-axis. You don't want to squish all your information here because you won't see the trend. You want to space it out. Use as much as the entire axes as you can, okay, as much as possible. It doesn't have to go right to the end, but close to if you can. This way you spread the data out and you can see a trend. If it's too squished, you won't see it. Okay, so go ahead and do that. One of the questions asks you here, says describe the relationship between the speed of the car and a stopping distance. There's a non-linear pattern. It's curved, which just means it's not a line. So it's non-linear. As the speed of the car increases, the stopping distance also increases, okay? Question C says an additional measurement produces the ordered pair 8546. So in the testing that they did, they found that if you 8546, what does that mean? Well, 8546, explain the meaning of this pair. I think I forgot to explain it. Oh, no, here it is. This means that when the car is traveling 85 kilometers an hour, it requires 46 meters of stopping distance. So 85 is the X coordinate or the X axis, which is speed. And the Y coordinate, the 46, is the stopping distance in meters. Okay, so if you're traveling 85 kilometers, it takes 46 meters to stop. It says, is it an outlier? Well, if I look at my grid, it would fall about there. And that looks like it's in line with my data. Remember, if it's an outlier, this would be way outside the data. Okay, it would be off course. Like, hang on a second, this doesn't fit the trend. Okay, an outlier is still okay. Whenever you're drawing a line of best fit or a curve, you don't follow that little outlier. It's just a one-off mistake. You know, it could be something that we can explain. But when you look at the dot, it should fall outside the regular course of data. And here, this dot does not. It's actually following in line. It looks like it belongs there type thing. So it is not an outlier. So I put not an outlier as it is in line with the data. Okay. I hope that was helpful for you and that you got some GDC practice there. And we'll see you next class.